Morning 3K. So today is our fourth lesson on looking at fractions, and today we're going to look at equivalent fractions. We have already looked at adding fractions and subtracting fractions and looking at tenths. Now we're going to use the fraction wall to help us find out what we mean by equivalent fractions. The first thing I'd like you to do though is try and remember back to the 3 previous lessons we did last week, and I'd like you to tell me or write down 3 things you remember from our fractions lessons from last week. So like we usually do in class, just write your 3 dots underneath the short date and see if you can remember just 3 things from the previous 3 lessons on fractions. So I want us to spend some time looking at the fraction wall, which you can see on this slide. If you look, the very top section is called a whole. Why do you think it's called one whole? Okay, let's look at the fraction that's underneath a whole. We call this a half. It's a half because the whole has been equally split into 2 equal pieces. Each piece is worth 1 half, 1 out of the 2. The number 1 is the numerator and the number 2 underneath the line is the denominator. The denominator tells us how many pieces there are altogether, and the numerator tells us how much of the part we have. So if we look at a half, we have 2 halves that make 1 whole, and we can see that in the picture. If we then look at quarters, that's the section that's got a 1, a line and a 4 underneath it. Can you see which fraction is the same as 1 half? Okay, so if we look, 1 half is the same as 2 quarters. We know this because if you were to put a ruler or a line at the end of 2 quarters, it would match the end of the line of 1 half. So, knowing that, I'm going to give you some time now to see if you can look at that fraction wall and see what other equivalent fractions you can find. And we can talk about what you found during our 30-minute session later on today. So I want you to spend some time looking at this fraction wall. You should have found lots of equivalent fractions. How can we actually use the fraction wall to help us? Now, this fraction wall I've put on most of the next few slides just to help you. Can you describe why fractions are equivalent and how they are equivalent? Okay, 3K, let's have a look at our in focus task. This boy here says, "This is my share. I get 1 part out of 4 parts." So, is it possible to get more parts but still have the same amount? Let's think carefully. So, what is the question asking you to do? How can you work it out? And why do you think the fraction wall is on this slide? So, let's go through this. The little boy said on the previous slide, "I get 1 part, 4 of these makes 1 whole. So he knows that he's going to get 1/4, which we know is called 1/4. There are 4 pieces in total that make the whole, and he's having one of those 4 pieces. So 1/4, which we know as 1/4. But we also know from our fraction rule that actually we can have more pieces but have the same amount. He says this one can be cut into 2 equal parts. If each quarter is split into 2 equal parts, what must the denominator be? How many equal parts do we have now? And if we look at our fraction rule, we can see that 1/4 is equivalent, the same as 2/8. Let's have a look at number 3. The boy said, I have 4 parts, but this one part can be cut into 4 equal pieces, but I still have 1/4. So, what must my denominator be? If each quarter is then split into 4 equal parts, what must the denominator be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the denominator for number 3 must be 16. I have 4/16, which is exactly the same as 1/4. Number 4, he says, try to get 12 equal parts from 1. If we look at number 4, how many parts make up a whole? At the moment, the picture shows 4 equal parts, but the boy wants us to get 12 equal parts. Let's cut each part into 3. So if we look, he now has 3/12. If you have a look at your fraction rule, you will see that 3/12 is equivalent to 1/4. 3/12 are the same as 1/4. This tells me that I can have more pieces, but exactly the same amount. And we know this because they are equivalent fractions. They are the same. 1/4 is equivalent to 2/8, which is equivalent to 4/16, which is equivalent to 3/12. All of those fractions are the same. Using the fraction rule, have a go at question 5. What can we say about 1/4, 2/8, and 3/12? How are they linked? Okay, so have a go at these 2 questions. I've got pictures as well as fraction numbers to help you. Have a go at them. Remember, we're learning about equivalent fractions, and equivalent means the same. So, using the fraction rule again, I want you to have a look and try and find as many equivalent fractions as you can. I wonder who's going to find the most equivalent fractions. Remember, you can have more than 12ths. Let's see who finds the most. Remember, they have to be the same. So a half is not equivalent to 1/3. Why not? But a half is equivalent to 2/4. Why? Okay, have a go at finding equivalent fractions on these 2 worksheet pages. Use the pictures to help you if you can. It's really important that you make sure that they are equivalent. Equivalent means the same. Here's a little bit of a challenge for you. Hamza says the diagrams below show that 1/4 is greater than 1/2. Do you agree? Explain why. And we can have a look at some of your explanations when I meet you in our 30-minute discussion session later today. Speak to you soon. Bye.